Welcome to a day in my life as a marine biologist who studies kelp. I consider myself a part-time kelp farmer because my job is to grow kelp for restoration. Today's main task is an inoculation, basically settling kelp spores onto substrate to be planted in areas of high kelp loss. Something fun we're going to try is to grow kelp on urchin tests. These ones were removed from our restoration sites where the urchin population has grown out of control. They'd been sitting in some bleach, so I cleaned them off with fresh water and set them out to dry so we could inoculate them later in the day, which was very satisfying. Sometimes we need to work with sterile seawater to avoid contamination from things like diatoms. So we use what's called an autoclave, which uses steam and pressure to sterilize our seawater. It takes 1 million years to fill the DI water, and once that's ready, I let it run for 30 minutes and then wait about another 30 for it to depressurize and cool down. In the meantime, we had some kelp growing in this tank, so I took a sample to see how it was doing, and at first I did not like what I saw. There were tons of these creepy worms, lots of diatoms, and I think these are ciliates. Anyway, this is the contamination we want to avoid. But eventually I did find some gametophytes, which are the microscopic life stage of kelp, that will eventually fertilize and turn into baby kelp like this. I then cleaned these tubes that we're going to put twine in to also inoculate with kelp spores. This is kind of the traditional method used to grow kelp on lines out in the ocean, but they are great for restoration as well. I then went and checked on the autoclave. The pressure was at 0 and the temp had gone down a bit, so I took out our flasks to cool. You have to be very careful because at this point it's still almost 200 degrees and there can be a lot of steam. We use autoclave tape, and I'm not sure if you noticed, but it starts out kind of a pale yellow, and when you're done it should be black if it was sterilized correctly. I needed these to cool ASAP, so I put them in our cold room where it's about 7 degrees Celsius. My lab mate did the spore release, which is the process where you take the reproductive material of the kelp called sori and get them to release the spores. This murky water had a spore density of about 1 million spores per mil, and then we were ready to inoculate. We put all of the urchin tests in a tank of water and poured some spore solution in it so that we would have a density of about 5,000 spores per mil. We cover it for about 24 hours so the spores will settle onto the tests, and then we did the same thing with the twine. Finally, we had some twine that we inoculated a couple of months ago that needed their weekly water change, so I did that and then I was ready to go home.